Assalamu alaikum dear friends. Today we are going to study about PRIMS algorithm. PRIMS algorithm is one of the very important algorithms which are used for minimum cost spanning tree calculation. It is normally used to find the minimum cost spanning tree when we have some graph. So I will explain step by step with the help of an example that how we implement PRIMS algorithm, what are the necessary steps to do it. But the main point that you need to understand is that whenever you are asked a question for PRIMS algorithm, then you have to be sure that you are actually going to find out the minimum cost spanning tree. I have already given you the concept of minimum cost spanning tree in my previous lectures. If you do not have an idea about that, then do visit my previous videos on uh, minimum cost spanning tree, its idea, its concept, and how does it operates. Okay, so first of all friends, if we have a graph which has v number of vertices, then you have to be sure that the subgraph should also have v number of vertices, right? And the subgraph should have edges which should be equal to n minus 1 or v minus 1. For example, there were 5 vertices, so the edges in the subgraph will be equal to 5 minus 1, which is equal to 4. So these are the two basic conditions that have to be true when we are applying PRIMS algorithm and applying minimum cost spanning tree. Okay, so now let's consider a weighted undirected graph. So basically this is a undirected graph. You cannot see any arrows, so that is why it is an undirected graph, and it is weighted because on each edge we are having some value which is not 1, which is something other than 1. That is why we are saying that it is a weighted undirected graph. So how many vertices do we have? We have 9 vertices. You can count 1 2 3 4 5 6 7 8 9. So how many edges? 9 minus 1 equal to 8. Okay, so now the question is asked that you have to apply PRIMS algorithm and you have to find the minimum cost spanning tree. Okay, so step number 1, we can start from any vertex unless specified. Let's say we are going to start from B. So in PRIMS algorithm, you can start from any vertex, right? You are not bound that you have to start from a specific vertex. Yes, if you are asked in the question that start from this or that, then you are bound. Otherwise, in PRIMS algorithm, you are not generally not bound that you have to start from some specific vertex. Okay, in this question we are going to start from B. So step number 2, select a minimum cost by considering cost of connecting next vertex, also considering cost of previous vertex. So what we do is, we are saying that this is my first vertex. So see, if I connect B with A, the cost is 1, and if I connect B with C, the cost is 6. So which one will I select? Of course the minimum one is cost 1. So I am going to select this edge as my my first working boundary. This is the point that I am going to select on number 1. Okay, so I have connected B with A. Now I have got this vertex A. Now just see, there is a connection between A and D which has a cost of 5, and there is a connection of A and C which has a cost of 6, and there is a connection of B and C which has a connection of which has a cost of 6. So out of these 3, of course this 5 is minimum, so I am going to select this 5 as my second edge. Okay, so this is going to be my second edge because the cost is low. Okay, so now the D point is connected with F with a cost of 2, and this D point is connected with G with a cost of 10, and this F point is connected with C with a cost of 3, and then F is connected with H with a cost of 8, and these are 6 6. Okay, so out of all these I can see, so you can very well imagine that I am not only considering the cost which is next to the last connected node, but I am also taking into account the previous connections which were left. So I find that this 2 is the minimum out of all. So I make this 2 as my third connection. Okay, so now F is also connected. So I will see that F is connected with C with a cost of 3 and F has a connection of cost 8. So F has basically two connections, and previously we do also have these two connections 6 and 6. Okay, but you can see that if I connect this 6 right here, then it will become like this is also, this is connected, this is connected, this is connected, and this is connected. So if I join this line by any means, I say that, oh, this is a low cost. So if I join this line, it will become a closed loop. A closed loop is also called a circle. So we do not have to make it a circle because we are making it a minimum cost spanning tree. A tree and a tree is never cyclic, or in other words, a tree is never cyclic. Whenever there is a cyclic pattern, it is no more a tree, it becomes a graph. So this is your first rule, that whenever you are making connections, you are joining the lines, do not join a line which makes your tree a circle or a cycle, a complete closed loop. Okay, similar is the case with this line. If you join this line, again you will have this closed loop, and which will be a circle, a cycle. So do not do that, please. Okay, so my next low cost was 3. So I joined this line. This is my fourth connection. First connection, second connection, third, and now this is my fourth connection. Now look at C. C had these two lines which I just explained to you that they are not to be considered. So the next line of C is with a cost of 7. 7 is bigger than 6, but because of this condition that we do not want to do cyclic move, so we connect this C with E through this line, and this becomes my fifth connection. Now E has a connection with H with a cost of 12, and previously, if we look back onto my previous nodes, F was having a connection with H which has a cost of 8. Now you can very well imagine that if I was only considering the costs next to my last connected node, then I would not have been considered 8. But of course 8 is smaller than 12, so I have connected this line instead of this line, and my new or my sixth connection became F and H. Now H is connected with G with this line which has a cost of 7, and there is this line which is 12. So of course 7 is smaller than 12, so I have not connected this line, I have connected this line. Do remember that if I had connected this line, again it would have been a circle. So even if 12 was smaller than 7, still I was not connecting this because I do not want any sort of cycle, right? So it will remain open, it will remain open, it will remain open, so that there is no complete closed loop. So I'm joining this. Now only one line is left unjoined. We will not join this line because we do not want to make here a circle. Now G point can be connected with I because we have reached on to the node G, and G has two connections, one is with D and one is with I. This connection will not be made because it will make it a closed loop, a cyclic pattern. So we will simply connect this G with I, and this is my 8th iteration. So now you can see that all the nodes have been visited. The requirement of PRIMS algorithm or the requirement of minimum cost spanning tree is that you make a subgraph in such a way that all of your nodes have been visited. So now see, my all the nodes have been visited. B A D F C E, and then you went on to okay, this is the sixth one. So we went from F to H, and from H to G, and from G to I. So all my nodes have been visited. This line is not visited because D was already a connected node. Similarly, this line is not visited because H is already a connected node. This line is not visited because C is already a connected node. All right, so the cost is, we will add these costs: 1, 5, 2, 3, 7, 8, 7 and 3. So the sum of all these costs become 36. So this is my cost of the minimum spanning tree with PRIMS algorithm. Meanwhile, we can see that in between everything is connected, unlike Kruskal. In Kruskal algorithm, sometimes your maybe these three lines are connected, 1, 2, 3, and instead of making this connection, we could also go here and make this connection, because in Kruskal we are following a different strategy. But in PRIMS, you see that everything is connected. Meanwhile, in between, you did this connection, this connection, this connection, this connection, and then because of this little cyclic thing, you skipped it and you went to this portion, but still this is still connected. You didn't go over there. You did this connection because this was again connected. So in PRIMS, always remember that you stay connected. You are this loop, this loop, this loop, this loop. You are not going on to this loop abruptly. You are staying within the connections. You're connecting the connected loops already. The only one important thing that you have to keep in mind, that whenever you are looking onto the costs to make next connections, you always consider the previous costs as well. For example, when you were connecting this F with H, then you consider that okay, there is a cost 8 over there, and there was a cost 7 over there, and you didn't do that. You did this one because this was lower than this. So you do not only consider the latest node connections, but you also do consider the previous nodes connections. So I hope you understand the PRIMS algorithm with this example. If you do, then please do like the video and subscribe to the channel, and write down your questions in the comments. Thank you.